ES Audio.
From the Evening Standard in London, I'm Rochelle Travers, and this is The Leader. We're going to have to wait a little longer for the launch of the European Space Agency's Jupiter Icy Moons Explorer. It was supposed to take off this afternoon from ESA's spaceport in French Guiana, but has been postponed due to bad weather. The hope is for it to go ahead tomorrow instead. Specific conditions are needed, and there is just a 1-second window to get it right. The mission is one of ESA's most ambitious projects ever, and UK scientists are playing a crucial part. The satellite, also known as JUICE for short, will make detailed observations of Jupiter and its icy moons. Ganymede, Callisto and Europa each are thought to have their own oceans, and the aim is to find out whether or not they could have supported life, or if they still do. Dr. Ben Dreyer is a research fellow at the Open University and is part of the project. Dr. Dreyer, first of all, can you just give us your reaction to the postponement of the launch?
Obviously, when it happens live, it feels like a bit of a disappointment, but I think it just really outlines the fact that they're being very cautious with this mission. It's one of ESA's L class, so it's the largest class of missions that they launch, large in terms of size and money. So they're being extremely cautious about taking any risks with the launch. The launch is the phase where the mission can go wrong the most, as we've seen recently with the launch in Cornwall. So they're just being very cautious, and any sign that the weather's changed and there might be a risk of thunder or lightning, they're just going to delay till the next day because there's really no cost to doing that.
The conditions of this launch have to be very specific, don't they? There's a 1-second window to get it all right.
Yeah, so the JUICE launch is doing something very special that we've never done before. Because it needs a lot of fuel to be left over when it arrives at Jupiter in order to do manoeuvres, to do flybys of the moons, and then to insert itself into an orbit around Ganymede, which is its final science target. We want to save as much fuel as we can on the way there. So what ESA is doing is doing this novel maneuver where it launches towards the moon, the satellite catapults around the moon, and in doing that, it absorbs some of the gravitational energy from the moon, which adds to its speed. And then after doing that maneuver around the moon, it does the same maneuver again around the Earth. So it's a double catapult in order to get as much speed as possible to catapult it towards Jupiter. So this, when we're talking about this 1-second window, it means that the moon and the Earth are in the right orientation, that we're able to do this maneuver in the safest possible way. But luckily, the launch has failed today, but there's a 1-second window in each of the days in the rest of April because, the moon keeps on orbiting and we get a chance every day. It doesn't move out of sync too much each day. So we've got a few more chances before the end of the month to get a successful and safe launch.
Now let's get into the details of the JUICE mission. What is it exactly and how will it all work?
Yes, so it's really, well, I should begin by saying it's the furthest into our solar system that we've sent such a well-equipped laboratory. We've never really sent a scientific laboratory that's so well-equipped past the orbit of Mars. So it's our first real insight into planets which are very different to ours. So our inner solar system is Mercury, Venus, Earth and Mars, and they're quite rocky and they're quite similar to Earth, although obviously different in other ways. But the planets beyond Mars are made up of gas, and they're not really anything like the Earth or the rocky planets. So it's really the first time that we're going to get really detailed measurements of these gassy planets so that we can begin to understand them. One of the key science goals of the mission is to understand if there is a habitable environment on Jupiter or any of its moons. Really, a couple of decades ago, you would have been laughed at if you suggested that the gas giants were a likely place for life to live. But in fact, our understanding has evolved, and we've found very little signs of current water or life on our rocky neighbours. But Galileo, which was a spacecraft launched at the end of the 80s and orbited in the 90s, it was able to work out that Europa, which is one of the icy moons of Jupiter, has subsurface water, so liquid water underneath the surface. And so JUICE and indeed NASA's Europa Clipper, which is a mission which is launching next year, are both going to Jupiter to try and get more information about these possible habitats for life. They're not equipped to be able to detect life, but they're equipped to be able to detect if all of the necessary ingredients are there for life to form.
And after the launch, we're going to have a bit of a wait. It'll take 8 years until it reaches its final destination, right?
Yes, so really the launch is just one stepping stone in the journey. It's going to take another 8 years to arrive at Jupiter. And so it's the beginning of 2031 that actual science operations will begin. And that's the moment where we get some data back from our instrument and we feel, proud that we've made that data happen. That's the real relief for us, that we're able to get some good data back and start doing some science. The launch is just a very, trepidatious stepping stone on the way to being able to return proper science data. And one of the issues with having that 8-year flight, so normally when we have space missions around the Earth, they might last for, say, 5 years. And the reason why we only operate them for 5 years is because there's a really harsh radiation environment. Once you go outside of the Earth's magnetic field and atmosphere, the radiation really degrades all materials that you put out there in space, and this affects the astronauts and all sorts, anything that goes outside our atmosphere and magnetic field. So normally we say, right, 5 years, the instrument's too damaged to be able to do good science anymore. We stop running the experiment because it's just not returning good data anymore. The real challenge with JUICE is that you're going to be 8 years in space before you even get to start doing the science that's necessary. So that's been one of the big challenges, and that's the focus of my research group.
What is the Open University's role and your role in particular in the project?
Yeah, so my research group at the Open University is called the Centre for Electronic Imaging, and we work with a lot of European Space Agency missions and a few NASA missions and other space agencies around the world. And we're really interested in how you design and build cameras for space missions. As I said, one of the big limiting factors of these space missions is the radiation damage. Once you get outside the atmosphere and the magnetic field of Earth, which shields us on the ground from this radiation, you start getting intense degradation of materials due to these particles that are flying around in space. So your image quality slowly degrades over time, and you end up getting worse and worse data as the mission goes on. So we try and understand in real intense detail how that damage happens to the cameras, how we can design cameras better so that they are less affected by it, and also how the scientists can correct their data once it comes back from space, because we understand what that damage should look like and how to take it out and only leave the real data that the scientists want to use.
Can you just give us an idea of the scale of the project, the teams involved and the years of work that have gone into this?
So kind of a large mission like JUICE, it's probably been going something like 30 years from the very initial design concept through to what we have today ready to launch. I believe it's 23 nations in Europe who have contributed to the project. And I know that the Japanese Space Agency and NASA have also contributed some parts to the mission. In terms of UK involvement, over £9 million was given to the UK Space Agency to be able to fund UK involvement in the mission. And that money was split between some of our world-class space research institutes. So that's us at the Open University, Imperial College, University of Leicester, MSSL, which is a space centre at University College London, and Aberystwyth University.
When it finally does launch, how big of a moment for the UK will it be in terms of our space efforts?
I think this, seeing a successful launch after what happened with our own attempt at launching from Cornwall, I think being able to see a successful launch that we've had such good scientific and engineering involvement with, I think that's really going to help to bolster people's re-interest in the space industry in the UK. We've got such a strong space industry. So, for example, we've got Teledyne e2v in Chelmsford as a company that makes these space cameras that we work with very closely, and they contribute to the cameras on lots of ESA missions. And so it really, seeing another successful mission come out really bolsters the desire to get into the space industry and do more good work.
Let's go to the ads. Stay there to hear from Dr. Shivangi Sharan from Imperial College London about how she'll be using the data collected from JUICE. Welcome back. Dr. Shivangi Sharan is a research associate at Imperial College London.
So Imperial College sent the magnetometer. So the instrument that measures the magnetic field, that's the magnetometer, was built by the Imperial College team. And we also have some instruments from other teams that includes scalar magnetism and scaling. But the main magnetometer was built by the Imperial team. This mission mostly focuses on Ganymede. So yeah, we really want to know, like, Ganymede is the only moon in the solar system which has its own magnetic field. And Ganymede has a magnetosphere that's embedded in the Jupiter system. So the interaction between these two systems and studying Ganymede in general is quite interesting. So what we usually look for life, when we usually look for life, we look at the innermost planets. But this would be interesting, since if life can exist even farther away from the sun, that would be a really cool thing to know. And this is kind of a new planetary body section, like it's the water worlds or the ocean worlds. And we could also look at some exoplanets that have similar conditions and see if life could be found there. So it would give us an insight into this new term, like what water worlds contain and what their interior looks like. So my work starts now. I'm basically working on prioritizing the research that will be carried out when we get back the JUICE data, so the JMAG data in specifically. So when we get back the data, we want to analyze them according to the sources of the magnetic fields, and we want to prioritize what we want to do first. And then, so that's what my work is basically. So I'll look at models and predict what data we can get, and then try to analyze how much we'll know from what data.
How will you feel when it eventually successfully launches?
Oh, I'm just waiting for the moment now. It's like I'm too excited for it. It's my whole work is depending on it. So I really want it to work, and it's really exciting to see a mission launch in front of you, and then you know that you're going to work on the data that you get back. So I'm kind of at the starting point, and I'll go with it along. So it's really cool.
You can read more about the Jupiter Icy Moons Explorer mission on our website, standard.co.uk. And that's it from The Leader. This podcast is back tomorrow at 4 p.m.